Thank you everyone for joining us today. I'm Mosa Emamjomeh, Executive Director at CTG Federal. With me, we've got Bob Ciotti, our Chief Architect for HPC and AI, and Steve Grewal, our CTO. Bob, would you like to give an introduction for yourself and a background?
Sure. I'm Bob Ciotti at CTG Federal. I am leading their effort in moving into the HPC and AI environment. The company's historically been very active in the enterprise space. It's clearly a leader in that area. And so we're combining that enterprise expertise with HPC and AI. I was at NASA for 35 years in a variety of roles, moving from sort of technical lead and chief architect to CTO in the division at NASA Ames, building their biggest supercomputing systems.
Steve?
Thank you. Sure. Steve Grewal, CTO here at CTG Federal. Before joining CTG Federal, I was Vice President Federal CTO at Cohesity. Cohesity is a leading data management, data protection platform. And before Cohesity, I actually spent 16 years in government. Most recently, I was the Deputy CIO at the GSA, managing the agency's internal operational portfolio, as well as managing shared services for external agencies and customers. Before GSA, I was with the Department of Education. I served in a series of leadership roles at Education. I originally joined to help them run infrastructure operations. They were one of the early adopters of a COCO contract at the time. Contractor owned, contractor operated. Think of early days of managed services, early days of cloud. So a lot of the same principles. The technology wasn't as mature, but really coming in and putting a framework and the right accountability around that. From that, I moved into the Chief Information Security Officer at Department of Education, overseeing and managing their national cybersecurity program, and then eventually CTO and CIO. And in addition, I have another 8 years at DOT and HHS. So 16 years in government, and then had a chance to learn the ropes at an OEM and now supporting customers at CTG Federal.
Awesome. We're blessed to have both of you as part of our team. And so today I want to ask you guys a bunch of questions about HPC and AI and how that relates to the federal government and our customer base, those agencies. Both of you have storied careers with the federal government. And Bob, how have you seen the evolution of HPC and supercomputing during your tenure with NASA?
Well, I think the big change is it went from sort of a capability that only the government could afford at scale, very large scale, $100 million sort of investments that was pretty risky in the early days. And what's really changed is that everybody really has to have it today. Some sort of either engineering or modeling capability. It's sort of gone mainstream. And so it's gone from sort of very sort of tenuous R&D activities to something that's really depended on in sort of a day-to-day basis to be competitive and productive in today's environment.
Wow. How about you, Steve? Any use cases of AI that you saw during your tenure with the government, or any changes that enabled the future use of AI at the agencies?
Yeah, I think the emphasis on data in general. Obviously, now we're seeing the scale, the capacity, the elasticity with innovations like the cloud and what have you. But looking back over the last 10 plus years, the government has a wealth of data, right? I mean, the one thing the government has an incredible amount of is data, right? Just a lot of data, a wealth of information across all the various mission areas, whether it's the IC, the DoD, the civilian space. But I think one of the challenges was a lot of these data assets, have historically been fragmented. There's a lot of data silos. You have various mission systems. You have various integrators, and you not necessarily, I think, as those systems are stood up, thinking early in the SDLC, you don't really have kind of a common data framework and a common data architecture. So some of my work at Education, the GSA, kind of predating even some of these next gen AI initiatives was, how do we get a more data-centric architecture, a common data framework, and looking across all of these systems, right? I mean, legacy terminology, whether there were OLTP systems or OLAP systems back then, or even thinking about concepts like ETL to help normalize these systems. Those were normalize the data layer essentially. A lot of my work was focused on those type of initiatives where, how do we not necessarily, hinder the progress or the pace of some of these development efforts, but as we think enterprise-wide, how can we truly have a layer of data that we can plug and play, whether it's prototyping, whether it's MVPs, whether it's large-scale initiatives. How do we really establish that type of, and again, it was a work in progress. And I think in 2019, the OMB issued some guidance around formalizing the chief data officer role. They stood up a CDO council, and that brought some, I think, explicit focus to data. But again, just some of the bureaucracy, some of the organizational constraints. I think it's still a work in progress. But a lot of my work was focused on getting that data under one coherent umbrella.
That's actually a great segue to our next topic, data governance and what role data plays in AI and HPC. Bob, do you have any opinions on data and data governance in general when it comes to HPC?
Sure. I mean, I think the real change there is that sort of you have these very individual projects, right? And they're very focused in a specific area. They've encoded their data in such a way that it's not easily accessible to programs or people outside of that. And then you tend to collect a lot of it, moving from petabytes to exabytes of data. NASA certainly has tremendous amounts of observational data.
Right.
Then it's computed on, maybe modeling outputs, and they're in formats that aren't really easily accessible.
Mm-hmm.
And so in order for you to train models and to make better sense of that, it's like, how are you going to annotate that? How are you going to discover, what information's in there that you don't know about? And so that's really the challenge. And so that involves things like metadata tagging, developing databases that are sort of accessible and can be queried, machine learning type infrastructure, wants to read those. How do they read and interpret and create the sorts of associations that you're looking to discover?
So you said, NASA collects a vast amount of data, computes based on that data, and then has outputs. So really, it's exponential growth of that data, right? Is there any initiative or has there been any discussion around managing that legacy data, retiring it, archiving it, or is all of that data readily accessible and needs to be maintained for the life of the agency, I would guess?
Well, so I mean, it's a very expensive problem, right? And so for observational data, for instance, you have your initial observations and then you're creating derivative data sets from that that are more valid scientifically.
Right.
And so you periodically do want to go back to the raw data and see, well, did I interpret it correctly the last time I did this? Or I've got a new algorithm that I want to recompute. And so you're constantly going back to the original data. You're generating these higher level data sets, and then scientists are getting access to that and trying to learn information from the observations. Mm-hmm. And so, yeah, you want that process to be more efficient and faster. You want all the data to be accessible, and it's a huge problem.
Steve, how about you? Any challenges you see with these government agencies in managing the data, ensuring its integrity, the quality of that data to be used for these AI use cases?
Yeah, I think, the volume of data certainly is one consideration, but, like you said, the accuracy is a whole nother consideration. So I think having authoritative data sets, right, that are utilized kind of horizontally, vertically in the organization is key. I think that goes back to having a data asset inventory, understanding your data assets, understanding, who are the mission owners, how is that data essentially kind of kept up to date. And I would say, the other kind of systemic issue is we certainly started to move into cloud in a big way in 2009. I think the OMB came out with a 25-point IT reform plan. You had the cloud first policy, which then turned into cloud smart. So we kind of had a tailwind of innovation. A lot of that early on was SaaS based, right? I mean, a lot of platforms that were SaaS based. Eventually, we started moving into cloud, refactoring, retooling applications. But again, I think what you had was this kind of ecosystem of a distributed, data footprint, right? So I think now it's a behemoth effort, a Herculean effort to kind of go back and refactor all these things. So I think data pipelines, right? I mean, there's various observability tools out there and platforms now where this whole notion of data pipelines, where you're able to leverage open standards and you're able to move data from any source to any destination in a mechanism where you need to do so. So I think it'll be a very big lift to kind of go back and take some of the legacy systems and refactor those in an efficient fashion. So I think we have to look for some of these emerging technologies where you are able to implement data pipelines, and then to your point, focus on the data integrity, because there's a lot of information out there. I mean, there's been a series of initiatives and constructs, whether we think about cyber with continuous monitoring or CDM, whether we even think about inside the agency how they track and monitor system owners. But my experience was a lot of data, but the data was not always clean and accurate. So, which of course, I know we're going to discuss later, goes directly into potential constraints for AI use and AI adoption.
So, Bob, the government obviously has a lot of data that they've collected. Do you see any potential issues or sensitivities around using that data to train AI or to use in HPC computations?
Yeah, I think that's a very big problem, actually, right? So the volume of data that's collected and stored is, a lot of it's sensitive, personal information, can be used to infer things about individuals, and so the government has a very big responsibility to ensure that privacy is maintained, right, but also has an interest in learning helpful information from that. And so there's a project in the DOE to actually look at, this might be the DOD, to look at veteran data and to derive health outcome information, right? So do proactive medical inference to rapidly respond or more rapidly potentially identify problems or potential outcomes for patients before a doctor would even see the patient. And so based on the information that they've collected from other individuals. And so that could be tremendously helpful and beneficial to people, but it could also have privacy concerns and other potential ways for the information to be abused.
Right. That's interesting. So, talking about the veteran data, that plays into HIPAA policies and policies around how that health information can be used. So, Steve, do you see any challenges of interpreting data privacy policies when it comes to AI, under the lens of AI, or do you foresee any new policies coming about that would be specific to how that data is used in AI?
Yeah, so right now, I think most agencies, departments, and CISOs that we work with are leveraging existing risk management practices for the AI ecosystem, which aligns with, if you look at the OMB guidance, M-2410, which came out in late March, which basically is guidance for government on use, responsible use of AI, innovation of AI. It very much focuses on that. Hey, from a privacy sensitivity perspective, the processes that you leverage today for ATOs and things of that nature should very much be implemented and enforced for AI. To your point earlier about understanding the data flows, having a robust understanding of like the mapping across your internal systems and how that data is flowing externally, vice versa, is very important. And so I think, this kind of reminds me of APIs. When APIs first came out, they were super powerful. There's a lot of excitement. But the pace of innovation was outpacing security policy and privacy. And then we had this whole market around API security. So I think a lot of the governance around use of LLMs and RAG and how all that comes together for now will be very much under the FISMA compliance kind of risk management ecosystem that CISOs are responsible for. And I do think over time, as the processes mature, as we have additional use cases that are out there, organizations like NIST will put out specific guidance and special publications which may augment the work that's being done today. But I would say current state, it's very much about ensuring the security posture that's leveraged for other security work streams and other compliance ATO work streams that are there today.
So I was interested to know, what are your thoughts on technologies in AI and HPC and the rapid pace of innovation?
Well, it's clearly changing very quickly. Just
Right.
the way that your training models, obviously generative AI is really exciting.
Right.
And the types of machines that you need for that are evolving monthly, right?
Right.
And so floating point formats are changing, algorithms are changing. And so how do you develop a plan to adopt this technology in such a rapidly changing environment? And so it's going to require substantial planning and investment.
Mm-hmm. Steve, what are your thoughts on the rapid pace of innovation in the field?
Yeah, I think it's here. It's disruptive in a positive way, but readiness, of course, I think is a key consideration. So everything from people, skill sets, process, systems architecture, you name it. I think all that needs to be reevaluated to some extent. I do think the kind of the phase one adoption of AI, a lot of what we talk to customers about in here. There's a lot of chatbot scenarios that we're hearing about with Gen AI, just for that level of interaction, better access to information. We had a lot of static knowledge bases in our time, and I think a lot of that is changing in a rapid way. In addition to that, I think process automation, right? I mean, before the kind of the AI piece took off, I think even a few years ago, there was a lot of focus and attention on things like RPA, right? Like robotic process automation, which was, hey, let's just take these manual tasks that a lot of our workers may be performing and we can automate those. I think AI is that on steroids. And I would say that the second piece of this is very much about even systems. I mean, there's a lot of systems out there, whether it's interagency interfaces, movement of data, manipulating data, batch jobs, I mean, spreadsheets. I mean, there's so much stuff like that, I think, that is also being automated in a big way, freeing up time, freeing up resources to focus on other things. So I would say those are the two areas that are being talked about the most today. But I would say we're going to see very much an escalation for all mission components in the coming years.
So you brought up a good point with these chatbots and interacting with the data. How do you think that's going to impact agencies with civilian-facing services?
Yeah, I think it's going to be a major tailwind for customer service. Of course, I think the back-end architecture, as we were talking earlier about data sensitivity, privacy, making sure that those elements are under control and data is flowing accurately. But I think in terms of servicing constituents, servicing our citizens, I think is overall customer satisfaction, customer improvement. It's going to be a major tailwind. I think it's going to have a lot of positive outcomes. Even years ago, I know there were initiatives with the GSA for centers of excellence to just even do call center consolidation, right? I mean, just the number of call centers that are out there we have to interface with and deal with is not efficient. But I think if we can automate that, we can empower the customer, the constituent, the citizen with the information and the data they need. I think you're going to see faster response times and you're going to see an increase in overall satisfaction.
I think from the scientist engineer perspective, you're sort of going to build this hybrid computer engineer person, right? And it's going to be the AI system is going to enable the engineer to have sort of instant access to huge volumes of data, right? To query, and so it's an augmentation on humans' perception, right? And humans' thinking process of how they interact with the data, how they discover things, and you end up with this hybrid engineer or hybrid scientist that is querying these volumes of data and combining that with human intelligence to rapid the pace of innovation and discovery.
So, we've seen this in the past, the challenges of these new technologies coming into the government. So in the past, it was shadow IT and the cloud, where developers were moving workloads into the cloud for dev test purposes. And today we see government agency workers or civilian servants utilizing Gen AI to craft policies or write something as simple as writing emails. So what do you think are the challenges of adopting this new technology for government agencies? Either the policies around it or the technology behind it. What do you think some of those challenges are?
Well, I think one of the big challenges is going to be what data you're incorporating into these models and who owns it, and then ultimately what that data is used for. Certainly, writing an email or responding to some questions is pretty innocent use. Mm-hmm. But were you able to use information that you shouldn't have had access to answer those questions?
Right. Steve, how about you? Do you have any opinions on this topic?
Yeah, I very much along the lines of what Bob's saying. I think, categorizing kind of the benign use cases that aren't super impactful in terms of negative outcomes. So I think it's going to be a balance of not over governing but not under governing. You want to have you want to start somewhere. You want to have a foundation in place for guidance around use. You want to have some level of policy, but you also want to make sure you don't rapidly start to move out on things that aren't proven, that aren't mature, and causing some level of damage, potentially even security incidents, things of that nature. So I think it's going to be very much about kind of a crawl, walk, run approach, and you not hindering or discouraging the use of AI. You want to empower the workforce, both civilian employees and contractors, but at the same time, you also want to make sure that you have enough guardrails in place where, since this is kind of a work in progress, you're not there's no exposure or breaches per se.
And I think the other thing is the answers that you're producing, the person who is reading the answer really has to have the expertise to know if it's correct, because it could be wrong, yeah. Right? And so is the information that's coming out of your models actually correct or not? And so there's got to be a validation phase of, this is the output. Does it make sense? Is it wrong? Or, is it actually a valuable inference?
Yeah, that's a great point. I think, we talk about like AI has, interesting, right? We talk about data integrity issues. We focused on that a bit today because there's a lot of data, a volume of data, but the accuracy is another concern. And then if you start to think about that along the lines of AI hallucinations, right, where you're getting, bad information, then that human exercising human judgment component becomes even more critical because garbage in, garbage out. So I think while it can be a benefit for the near term, you're still going to need experts and SMEs who can interpret that and act accordingly, with that information.
Awesome. That's a great segue into our next topic, which is the impact that AI has on the federal workforce and the civil servants. So Steve, how do you see the transformation in AI changing the roles and responsibilities of civil servants, and what strategies do you see being put in place to manage this transition?
Yeah, a great question, Mosa. I think very much like we saw, prior disruptions in government, whether we're talking about the cloud or other arenas, there certainly is a kind of an overwhelming concern about job elimination or things of that nature. I think it's very much going to be about reskilling and retooling. Most departments and agencies rely on things like individual development plans, where they have their kind of annual training requirements that are laid out. At a higher level, the Office of Personnel Management issues guidance around, training for specific labor categories. So I think you're going to see creation of potentially new labor categories, within the 2210 series, information technology management, or even the creation of new labor categories focused on this. And along those lines, I think you're going to need individual development plans, which are then reskilling individual employees on the training that they need. We just spoke about earlier about the need to still exercise judgment, human judgment against some of these, innovations and technologies that are going to be in place. So I don't think, you're going to have a scenario where everything is fully automated and fully bulletproof and good to go. So I think long term, we're going to be not eliminating, people or jobs. We're going to be eliminating particular tasks and then redirecting their attention and their energy towards other tasks that are still going to be required with this new world of AI.
Bob, how do you see that impacting the federal workforce?
So specifically in the context of scientists and engineers, I think there's a huge potential for improving the training aspect, right? So you're typically starting out with more junior engineers, maybe they're postdocs, coming in, sort of learning very specific aspects of the problem area that they're working in. And so there's a real potential to make that training more effective, more broad. And then in the areas of science discovery, right? So how could you use artificial intelligence to learn new things, right? To expand human knowledge, to build better aircraft or spacecraft, right? So how to make them more effective. So I don't think it really replaces people as much as it augments our existing processes and makes them more effective.
I love the perspective because I think there's a lot of headlines and fear-mongering about AI replacing people and taking over jobs, but it seems that from your perspectives, it's actually enabling people to do their jobs or become better at those jobs.
I think so. I think a huge potential win in productivity and more science gains, right? Just having better access to the engineering or the scientific data that you have and allowing people to more quickly understand it and to make progress.
So let's say people are still worried that AI is going to replace their jobs. What role can the federal government or should the federal government play in managing how AI is used at the different agencies and used in terms of day-to-day productivity?
Well, I think there are jobs that will be replaced, right? And so it is, incumbent on the government to be sure that education is a huge piece of this transformation.
Right.
How do you train people differently? How do you bring them into the revolution instead of rolling over them, right? And so, and I think it's going to be pretty disruptive in terms of the types of services that are needed, the types of things that you do with the data that you have. So there'll be a tremendous number of jobs that are actually created as a result of having this, just trying to apply that technology in the different areas that will ultimately have huge benefits.
So Steve, what are your thoughts? Can the government or should the government play a role in this transformation of AI in the workforce?
Yeah, I think absolutely. I think transparency and situational awareness is going to be key for just for easing concerns. The government has launched AI.gov, which I think is a great first step with the transparency piece. Part of the OMB 24-10 guidance I mentioned earlier had a data call for AI use cases across government. And that inventory of AI use cases is now posted on AI.gov, right? These are real life use cases by departments and agencies. So I think being able to go out there and see what's being done, how it's being utilized is going to be important for folks to get a practical understanding of how this is going to operate and ease some of their fears and concerns as we move into this next phase of adoption.
So yeah, and I think when I first started in the industry, we used to use a metric for how productive a computer programmer would be, and it was 7 lines of code a day. So you'd write 7 lines of code a day, and that included the planning, the pre-design, the writing of the code, the testing, and the deployment. And so what happens in an environment where it's 10 or 100 times more effective that I'm writing 1,000 lines of code a day? And so the need will shift from needing lots of computer programmers to needing lots of people that understand how to write or to develop machine learning algorithms and codes, right? So it's maybe you don't need programmers, but you need more sophisticated analysts to be able to come in and move the problem up, right? So we started with, when I started in my training, we had, you'd program computers in Octal. And so there was actually light switches on the computer for each bit, and we debug and program basically in assembly language. And today, you're programming in much, much higher languages, level of languages. And that power brings sophistication and brings the ability to make progress much, much more quickly. And so the types of jobs that you do, I think, are going to change dramatically. But the need for the number of people that you have, I don't see that that's really being impacted. It's more their skill sets.
Yep, and I think we saw the same thing with the cloud, adoption journey as well, right? I mean, skills, we had to reskill. We still needed resources and people to perform those functions, and it took us some time to kind of recalibrate and get the right training and the right skill sets in place. But very much so, a lot of the traditional infrastructure teams are now heavily engaged with managing cloud operations. I think we'll see a similar journey.
Awesome. So switching gears a little bit, I want to talk now about operationalizing some of the AI use cases in the federal government. So one question I had is, how can federal agencies integrate AI solutions, or should they integrate AI solutions into their existing workflows?
Yeah, I think there's potentially 2 approaches, right? So integrating in with your existing approaches, but I think the technology is so disruptive that a first principle design might be a better approach to certain cases. And by that, I mean that you're planning from the very beginning how you're going to store the data. I think you're storing the data today in a certain way. To make it accessible to AI, you really have to rethink how you store, encode, and access the data. These are very big problems. And without having, I think, dedicated efforts that are created to support this, right, that rethink from first principles. How am I going to handle the data that I have? How am I going to reorganize the data? How am I going to reorganize my workforce? How am I going to budget for this? And so anything that you talk about doing something just on the margin, right? Doing what my current job plus a little bit without actually rethinking the budget process and your workforce, I think is going to be actually problematic to implement things that way with such a disruptive type of technology.
Okay. Steve, what are your thoughts? Should the government integrate AI solutions into existing workflows? Should they look for new ways, start from scratch, so to speak? What are your thoughts?
Yeah, I think a clean sheet approach is probably the right answer because, as Bob mentioned, you certainly have a lot of process debt and technical debt in some cases. So I think looking at your current state, is meaningful and can be effective understanding it. But as you're thinking about where you want to go, that clean sheet approach is necessary. And part of that, could be the assessment of your current SOPs and your workflows. And some of those elements may need to be introduced into the new environment or the reimagined environment. But I think force fitting or backing into kind of what you're doing today with your workflows and SOPs may not yield the outcomes that you certainly want to strive for. So I think having that context and that baseline understanding of how historic processes and workflows operate will be important. But I think as you map out where you want to go in the future state of that environment, you can pull in the necessary components versus trying to manually integrate them with what you're doing today.
So you said, mapping out the AI use cases and what that's going to look like. What are some of the key elements the government agencies should look for when considering AI use cases?
Well, I mean, the easy ones, of course, are the chat bots, right? So how do I answer simple questions of the data that I have? But beyond that, certainly programming, right? So generating code is incredibly robust and capable. I mean, I'm actually amazed at how sophisticated it can be. Beyond that, inferring relationships in data that you didn't really know existed, right? And so this is actually the recognition of knowledge that already exists in your data. And so that's not a simple query. It's pulling together disparate relationships in data that you can't, a human looking at that can't really see it. And then augmenting human perception, I think, is really the big potential.
Steve, what about you? What do you think some of those key elements are that federal agencies should look for when they're operationalizing AI use cases? How do they map out their plans, so to speak?
Yeah, I think we touched on chatbots. I think we talked a little bit earlier about just general system processes, system level processes that can be automated. I think you're going to see a big emphasis there. To go a little deeper, I'm pretty excited about the cybersecurity arena, specifically in relation to incident handling and response, right? I mean, we're often dealing with a needle in a haystack analysis scenario where there's a ton of information. You need precision, you have to move at speed, and you kind of have to get it right against the adversaries. And I think as we're thinking about all these, the security ecosystem, endpoint tools, SIM tools, SOAR tools, your traditional server logs, your IDS, IPS data, all that stuff now kind of moves into a SIM, and then we've attempted to kind of orchestrate, automate using SOAR capabilities. But I think if we get the LLM pieces and the RAG pieces right, I think you can really expedite the security operations arena. And I think that is going to be incredibly important for national security, even for protecting internal data assets and systems. And that's one area that I think is going to be very much an emphasis in the coming years for CIOs and CISOs.
Everybody doesn't have access to the same level of healthcare in this country or even in the world. And the potential there is that very quickly people can have access to very sophisticated analysis of maybe an X-ray or a medical test that they're doing where they just didn't have access to that before. And so I think that that's a huge potential benefit in improving healthcare for everybody and potentially reducing the cost as well there.
I could see medical professionals rolling their eyes. This is WebMD on steroids.
Well, you can't, again, the computer's going to spit out something. Somebody has to look at it and say, yeah, that makes sense to me, or I can see it. So eventually it's got to get back to an expert human, but the ability to initially scan, the inputs and to say, hey, look for this or look for that. Point out potential problems that may have been overlooked because, a particular medical system was overloaded, right? To highlight areas where you really want to take a better look, maybe do another test.
Yeah, and looking at those combinations, I think at scale and at speed is going to be huge. Whether it's healthcare, whether it's transportation, any of the kind of the critical industries that government interfaces with. I think that scale and speed piece, I think, is what's going to be incredibly effective.
So now that we're talking about cybersecurity and AI, historically, what role has cyber played in HPC, and how do you see that evolving today?
So I think the big change is going from more passively monitoring to actively understanding what's going on. And so, this is already happening today with analysis of code, right? So you use artificial intelligence to identify problems in code, backdoors, critical vulnerabilities, and to address them before they're actually even deployed. Another aspect is inferring, activity, right? So is this type of activity problematic? Should I be alerted? And so I think you're going to more quickly be able to respond to potential threats, or identify weaknesses in your existing systems.
So now let's talk about how the innovations in AI and HPC are impacting the infrastructure that's used to support it. So one topic that I think is top of mind for a lot of people, especially with the different types of devices, GPUs, FPGAs, et cetera, that are required for these new AI use cases, is, what role does the cloud play? I'm sure they're looking at the long lead times of GPUs and wondering, is it best that I try to deploy this in the cloud? What are your thoughts on that, Steve?
Yeah, it's a great question, Mosa. I think, based on, 10 plus years of what we've seen in industry, based on best practices, right? Really the right model is a hybrid multi-cloud approach. So while for HPC workloads and AI, compute and scale and speed are incredibly important, costs are also key. There's overwhelming evidence now that we have that, all public cloud is not economical. So as you're thinking about, particular workloads, the requirements for those workloads, you can certainly leverage some components of the cloud, but really you want to design for and solve for a cloud-like environment in your data center, and then being able to leverage the public cloud services you deem fit on your own terms. We have a series of examples of customers who've kind of gone all in with the public cloud, and as they start getting their monthly invoices, they have sticker shock, and then they have to essentially kind of start to move back. There's examples of Fortune 500 companies who have gone through a similar journey of moving all public cloud and moving back. So, and also with budget formulation, right? That predictability as we're thinking about the cloud. I just don't think while there's a lot of benefits and power to the cloud when we're talking about these next gen workloads, we're actually seeing a lot of customers, procuring equipment, hardware, et cetera, in the data center to have, the scale and the capacity they need. So I don't think it's an either or. I think it's a combination based on your environment and what you're looking to accomplish.
Yeah, so clearly there's a lot of very good use cases for the cloud. They're typically, in environments where you have, you're bursting, or maybe you're doing sporadic development, or you have an edge environment. You're trying to connect to a lot of places throughout the world, or to develop maybe HA solutions, resiliency in your infrastructure. But for artificial intelligence and simulation and modeling, where you have highly utilized systems, you're going to want to bring that into your core. And so anything where you're running at 90% for months on end on a compute problem, and some of these training models run months and months on thousands of nodes. That's something that you will not afford to be able to do in the cloud, right? And so then you're going to struggle with developing your on-prem capabilities because these systems are changing. There are very high power demands, high cooling demands, and so traditional facilities are typically not capable to support these new systems. And so that is retooling your internal infrastructure, right? How do you bring in more power? How do you bring in more cooling? Probably going to move to a water cooling or liquid cooled type of environment. They're much more efficient, and you're able to get to the power density of today's modern systems.
So I've had a lot of customers, talk about the power constraints or the power requirements of these growing GPUs and AI use cases. What do you think are some trends or what innovations do you see around power and cooling that might help lower the cost of operating these systems on premises?
Yes, as you start talking about racks of equipment that are taking over 100 kilowatts, right? Mm-hmm. That sort of power density, you really want to look at what sort of efficiencies you have in step-down transformers, your power infrastructure, how to improve cooling, DC bus bars like in OCP, potential savings there. Your facility may not be well suited for that, but there's certainly some long-term operational efficiencies that are derived from improving your power distribution infrastructure and your cooling approaches.
Right. 100 kilowatts within a rack, that's a lot of power density, which requires a lot of cooling. Are agencies able to accommodate that with existing HVAC systems, or do they need to look towards direct liquid cooling, rear door heat exchangers, or what are some of your thoughts around that?
Well, air handling isn't going to handle it. And so you're either going with, in-rack CDUs, or you're adding in end-row CDUs, and so you're using water cooling. From the outside, maybe you're augmenting your existing infrastructure. Maybe you're even building in modules out in your parking lot, right? So that's what we did at NASA.
So with the increase of the power consumption of these AI systems, the GPUs, there's obviously some environmental concerns of the impact of the power consumption. What are your thoughts on that?
Well, I think that you're kind of on to something there, right? So how do you be environmentally sensitive to something that is so power hungry? And so that's really, I think, gets back to retooling your existing infrastructure. And so PUEs and historic facilities,
What's
may
PUE?
have, it's a measure of how much power I'm putting into my compute racks versus to do the computation versus how much I'm spending on things like cooling and maybe step-down transformers. And so it's a relative measure of the efficiency of how many watts you're putting in and how many flops you're getting out, so to speak. And so in a traditional aging facility, a PUE number of 1.5 means that for every watt I'm putting into the compute, I'm putting in a half a watt into cooling and step-down transformers and other inefficiencies. So in a modern facility, you can get those numbers down to an overhead of about 4%, 3%. We had some air-cooled facilities where we got down to 2.5%. Oh, wow. And so that responsibility, I think government absolutely has into looking and investing in these new technologies to improve power utilization. And that also includes updating infrastructure. Computers get more efficient over time. They do more for the same amount of power. The density goes up, so you actually use more power in the same footprint, but you get more work out.
Okay. And what do you think about new types of chips that are supposedly more efficient with the power? Is that, ARM? Do you think those devices are going to be impactful to the overall power spend of these data centers?
Absolutely. And so if you look at the lifetime cost of how much it's going to cost you to run your facility over a number of years, power is a big piece of that. It's a big number. And in fact, because of generative AI, the percentage of power that goes into artificial intelligence is increasing over time. And so that's going to make for more constrained power resources, which means it has the potential to raise the cost of power over time. And so even today, the lifetime cost for power usage and spend is a significant fraction of the overall cost of your system. That fraction is going to go up. And so technologies like ARM, very power efficient designs, trying to get more work for the same power footprint, are going to have big impacts in the long run. And certainly there's some big players in that space.
So, the next question I have is, we've talked a lot about the amount of data that the agencies are holding and how much data is required to drive, these AI use cases. How do the federal agencies manage all of this data, and what infrastructure is required to be able to handle that sort of data? What do you think, Bob?
Well, everybody talks about Moore's Law, right, on the compute side, but what Moore's Law did from a data side is it allowed us to produce much more data, huge volumes. And so this is the big data component that you hear about. And so now you have created these tremendous data stores, and now you actually want to look at them. And Gen AI and artificial intelligence in general, the access patterns that you see in codes like this is very different than the traditional computing access patterns that we would see on our historical systems. And so those types of storage systems that are optimized to make that efficient are very different. They're typically based in SSDs. They handle a large number of very small transactions efficiently. And so as a result, they're very different. And we also probably move into more tiering, right? So you may have a much smaller cache layer that's SSD based, a traditional hard drive layer, some way to get the data back and forth between those, maybe a tape system. And so the storage infrastructure is getting more complicated and more diverse to support these workloads.
So Steve, based on what Bob said with these different tiers of data, what kind of technologies or what kind of capabilities do these agencies need to be able to manage the data pipeline across these different systems? Or maybe they aren't different systems, maybe it's a data platform that they have. What are your thoughts around that?
Yeah, I think there's a series of data management and data protection platforms out there today that give you an incredible amount of ability, no matter if your data lives in a cloud native environment, if it lives on-prem, colo, SaaS, right? I mean, I think, given automation and given our ability to leverage orchestration capabilities, reconstructing the infrastructure is relatively simple. But your data is your most important asset that you want to make sure you have unfettered access to in the event of a disaster, in the event of a business continuity need. So I think, whether, depending on if it's tiered, if it's a hierarchical, system for your data, whether it lives in the cold storage in the cloud, you may have different policies and different SLAs for that data, but, ensuring that you are as resilient as possible, whether it's an operational outage, whether it's a cyber event, having one of these next generation data management platforms to back up all of your enterprise data, no matter where it lives, is a key focus. A lot of the customers we support today, if you look at their top three priorities for FY25 and beyond, an enterprise data management and data protection strategy is on top of their list.
So yeah, and I think there's also, you have multiple aspects to the data access patterns that you see, right? So one of them is this localized access. How am I going to compute on my data locally, right? Optimized for your HPC environment. But the other aspect is, how am I going to distribute it to the world, right? And so there are two very different requirements and needs, but you need to do both of them well.
So, one thing that I've had a lot of customers ask me about is the networking or the high-speed interfaces between these HPC nodes or AI nodes. And I think historically, a lot of that has been InfiniBand, but Ethernet has been growing and increasing its speeds. What are your thoughts on Ethernet or InfiniBand for these HPC networks?
Well, I think clearly InfiniBand still has the advantage in latency and scalability within a single system, but Ethernet's also maturing quite nicely, right? So you can use Rocky in these environments. That allows you to do RDMA over Ethernet. Ethernet gives you additional capabilities in terms of security. The devices that sit at the edge can do, deep packet inspection, things like that. And so historically there was much more of an issue going from InfiniBand to Ethernet, but those are becoming much more closely converged. And so you can bridge between those environments, route between them. And even in the context of InfiniBand, there's additional security controls and some isolation that you have in that environment where the right thing sort of depends on the environment that you're in.
So I've had customers with the impression that InfiniBand is finicky or difficult to manage, or historically has been unreliable. What do you think the state of InfiniBand is today?
Certainly that's historically the case. It's a very sort of arcane technology. You have to have a lot of very specific knowledge about it to ensure that it's working correctly. And then when something breaks, it's like, well, what is it? I dealt with very, very large InfiniBand systems at NASA. We actually built the biggest InfiniBand systems in the day, and well over 11,000, 12,000 nodes in a single layer 2 network. And debugging that is problematic. But if you switch to today, right, the technology's really matured. And so it's very descriptive in the types of errors that you get. You still need to have some background in InfiniBand to know what to look for, the types of errors that are problematic. In general, you want the physical layer to be clean, right? And you got to know where to look for that. And then once you have that, and if you've architected the network topology correctly, the reliability is very, very good these days.
Yeah. So, Steve, we had brought up cybersecurity as it relates to HPC and AI, and there's been a lot of talk and mandates out about zero trust. What are your thoughts on the impact for zero trust in the AI data center?
Yeah, I think it's very much applicable. As we saw a couple years ago, there was a series of OMB mandates, White House executive orders, and it started a lot of attention and reporting around zero trust. There's a series of pillars. If we look at, there's different agencies and different institutions use different frameworks for zero trust, but at a high level, right, you have identity, you have devices, you have networks, applications, and workloads, and then of course your data. And there's platforms that span across these pillars that can give you the capabilities you need. And then there's best of breed point solutions that also give you the capabilities you need. So it's not a one size fits all. There's certainly a debate underway right now whether the right approach is adopting a platform or is it using point solutions, best of breed point solutions. I personally feel that it's a combination because some platforms do a few things really well, and there's other things that, that's really not their bread and butter. But whether we're looking across those pillars and, depending on your requirements, your existing investments, interoperability, integration, how heavily invested you are in the cloud or you're not, all of those considerations help drive that. But for the next gen AI data center, as we talked about security, we talked about risk management, having a robust security architecture spanning across all of those pillars is going to be a critical success factor in rolling out AI, adopting AI in a responsible manner.
Thank you everyone for tuning in today. If you have any follow-on questions or topics you'd like to discuss, please reach out to your CTG Federal account executive.